There are a couple of questions available. The first one is about something, I guess, that you didn't have a chance to cover, and that's essentially around the kind of the assumptions that underlie these methods. So, is it the case, for example, that these methods work equally as well when we have skewed data as when we don't have skewed data?
Yes, that's a really good question. It was something that we found fairly consistently throughout the methods that we looked at, that often they reported that an underlying assumption was normality in the data, and so we deliberately stress tested the methods by testing them out on an outcome that we knew had a skewed distribution. And so both from simulation study results in the literature and from our case study findings, it seemed that the methods are quite robust to deviations from normality, even though that's explicitly stated as being one of the assumptions.
Okay, thanks for that, Chris. The next question is really, I guess, thinking about the sequence of steps that you might take in terms of, thinking about your primary analysis and sensitivity analyses. Have you got some advice around what you might structure as your primary analysis? And so should that be the analysis that includes these trials using some particular method to impute the standard deviations or means, or would you advocate for an analysis that was basically an available case analysis of the trials that had reported those means and standard deviations as the primary analysis?
Yeah, that's a really good question. I think certainly some form of sensitivity analysis will be required in this situation. And what I didn't talk about today, but is available in the supplementary material to the paper that I referred to reporting our work, is that in some scenarios, omitting the trial from the meta-analysis doesn't necessarily provide such risk of bias or problems with precision as we found in the particular case study that I reported today. So I think it's certainly sensitivity analysis will be required. I think my personal preference would be to, as the primary analysis, try to include all of the data available, and therefore that involves using some of the methods that we've talked about today with their accompanying assumptions. It feels like, from an ethical perspective, to try and at least try and make use of all the data from studies where participants have consented and undergone the intervention seems appropriate, but certainly sensitivity analysis will feature, and probably one element of that sensitivity analysis could be omitting the trial from the analysis to see if it actually impacts on the conclusions at all.
Okay, another question, which I guess you kind of alluded to, is around whether you've had a chance to investigate how these kind of simple methods compare to Bayesian meta-analysis in terms of performance metrics such as bias and precision.
Yeah, so in a way that is a gap in what we've done, because we're taking that perspective of looking for methods that would be potentially applied in scenarios where there wasn't an expert on the topic of analysis that available, whether that's Bayesian analysis or meta regression or whatever. So we didn't do head-to-head comparison of, if you like, the complex versus simple methods. I think that would be really interesting to see those findings. As far as I'm aware from the literature, I haven't seen many examples where that's been done, but I think it would be very useful to either, help confirm or refute the validity of using the simpler methods in this situation. What we did find was in using the methods in the example, for instance, that we talked about today, that it was possible using the simple methods to have levels of bias and imprecision that were minimally important. So in that particular case study, it didn't matter the deviation between the imputed result using the simple method and the true result based on all the systematic review data. But I do agree that actually some further work on that comparison between simple and complex methods would be a valuable addition as well.
Yes. So a further question is around kind of considering the certainty of the evidence. And really, when we're kind of, making assumptions using these methods to impute or recreate these missing statistics, do you think in any way we should, that should change the way that we consider the certainty of the evidence ultimately of our pooled effect? So when we do, for example, a grade assessment, should that somehow feed into there that for some of the standard deviations and means, they're not actually known, but they are calculated in some way using some method?
Yeah, that sounds like an excellent suggestion. It's not something that I actually considered, but it does. It has value, I think, in terms of the transparency of the review process, so that those assumptions that have been made as part of the analysis are actually carried through to feeding into the overall consideration of the level of evidence. So I think that's a very helpful suggestion.
And do you think where that would how that would feed into, when you think about the kind of grade domains, there's imprecision and of course risk of bias and so forth. Where do you think that might feed into? Would that be around imprecision potentially?
I think it's probably imprecision and also risk of bias. It depends what's leading to a lack of reporting. So whether, for instance, it might be smaller studies that have more of a tendency for unreported means or standard deviations in a particular context. So it feels like it doesn't fit entirely in the imprecision box, but the bias probably needs to be one aspect of it as well. Okay,
and we don't seem to have any further questions, so I'll just ask one further question and then we'll see if anything comes up. I guess my question is around, in terms of the kind of, the case study that you looked at, obviously the results may be quite dependent on the particular data set and the intricacies of the data. And whether you had the opportunity to kind of run some other simulations that were independent of that data set to see whether you were observing similar patterns and, for example, whether you investigated how these methods operate when you might fit a fixed effect model versus a random effects model, and so forth.
Yes, thanks for that. Didn't have time to talk about it today, but in the paper reporting the results of the methodology reviews, we use a more simulation-based approach, drawing on data from a different stroke trial, and use that as a basis to construct a whole host of different meta-analysis data sets, some just with small trials, some just with large trials, some with a mixture of trial size, looking at the use of fixed and random effects, and so on. And I think in that case the results were perhaps less striking in terms of the differences between the methods, and I've really been reflecting a lot on why that might have been, and I think it's possible that we, in generating those simulated meta-analysis data sets, perhaps underestimated the trial-to-trial variability in the simulation. So it feels to me that that might be a key factor when in scenarios with greater trial-to-trial variability, that perhaps these methods might particularly offer an advantage, whereas in scenarios with rather less trial-to-trial variability, then very broad brush approaches like omitting the trial with the missing summaries might be sufficient.